calculator class which has got an R equal method. And if you look at this method, it's very simple. All it's doing is it's taking in two values of type integer, comparing those two. If they're equal, it returns true. Otherwise, it returns false. Now let's see how to use this method. Now let's say Boolean equal is equal to, since the method is a static method, I can just use the name of the class instead of creating an instance of that. Let's say, for example, if I pass 1 comma 2, they are not equal. And then if equal, we want to say the numbers are equal, otherwise not equal. Very simple code. Now if we run this, obviously since these are not equal, it will print not equal. That's fine. But then the issue here is, if you look at this calculator class and this R equal method, now this R equal method is actually tied to the data type. Now let's say the user wants to compare two strings if they are equal, or the user wants to compare two characters if they are equal. Now can he use this method? He cannot, because this method only works with integer data type. So your method is basically now tightly coupled with the data type that it operates upon. Okay, so if I make this method, let's say for example, I want to compare two strings, maybe A and B. Look at that. The moment I do that, you already have a red squiggly there indicating a compiler error. Okay, so obviously the error message, it makes sense. The best overloaded method for calculator.r equal int comma int has some invalid arguments. So it's expecting integer arguments, but you're passing string arguments into this method. So obviously it doesn't compile. So how do I make this method operate on any data type? Because the logic is pretty simple. If they are equal, return true, otherwise return false. So it need not be tied to any type. Okay, so how can I do that? One way to make this method operate on any data type is just replace this integer with object data type. Okay, the moment we do that, look at that, the error goes away. And look at this, this is A and B, they're not equal. If I run this, obviously it will say not equal. But on the other hand, just to make sure it is working as expected, A and A, I run this, okay, they are equal. So now if you look at this, this method is reusable with any type. It's not now tied to any type. But the problem here is, and why are we in the first place, how are we able to do this? If I convert the data type from integer to object, then I'm able to pass strings, I'm able to pass integers. How is that possible? We know that within .NET Framework, every type directly or indirectly inherits from system.object. So obviously you can, since string, integer, any type you take for that matter, directly or indirectly, it inherits from system.object. So you can pass that type as an inherited type into this method. That's how it works. But then the problem with this, there are two issues with this way of coding. One is, let's say for example, if I pass 10 and 10 integers. Now, when I actually run this program at runtime, what's going to happen is this 10, we know integer is a structure, which means it's a value type. So at runtime, this value type needs to be converted into object type. Object is nothing but a class. Look at that, the IntelliSense class system.object. But whereas integer is actually a structure, a value type. So at runtime, this value type needs to be converted into reference type, which is nothing but your class. So converting value types to reference types is called as boxing. So boxing is happening unnecessarily here just for the purposes of comparison. Okay, so because of this unnecessary boxing and unboxing, what's going to happen is the performance is going to be degraded. That's one problem. Another problem with this method, look at this. Now, if somebody is calling this method, okay, now the reason why they call this method is to determine if two values of the same type are equal or different. For example, I want to compare if two integers are equal, or if two strings are equal, or if two characters are equal. But since now you made this type as object, users can say, okay, I want to compare if 10 is equal to AB. Now this doesn't make sense. You shouldn't be allowing that in the first place. But here our code will happily compile because what is the type that we are dependent upon? Object type. So you will be able to pass in anything for the first parameter and anything for the second parameter. Okay, so now this method is no longer strongly typed. We lost that, we lost the strongly typed nature of this method, number one. And number two, because of boxing and unboxing, there is performance degradation. So to solve both of these problems, we can actually make use of generics. Okay, so the best way to make this method independent of the data type is to use generics. Let's see how to do that. So obviously, we don't want to be doing stuff like this. Let's say I want to compare AB with AB and determine if they are equal. Okay, so let's see how to correct that. So now, instead of object type, what I can basically do, see, it's using generics is very simple. Okay, all you have to do is put an angle bracket. See, I want to make this method generic now. Generic meaning I want to make this method independent of the type it operates upon. Okay, so what I'm doing here is I'm going to say some type. I don't know about the type. Okay, and the parameter that the user is going to pass in is going to be of this type t. Okay, so what is this t? We don't know. It could be integer, string, enum, whatever. It will only be known by the calling client. Okay, when somebody calls this method, that's when they specify on what type they want this method to operate upon. And then here we have to do a slight change because this is a type. You cannot directly compare them like this. Instead, you have to use the equals method which system.object provides to every type within .NET Framework. Okay, so T, we know that one is value 1, the other one is value 2, and both are of type T. Okay, so if value 1 dot equals value 2, okay, return value 1 dot equals value 2. If they are equal, it will return true, otherwise it's going to return false. Now look at this, there is no hard-coded logic here. We are not telling on which type this method is going to operate upon. All right, now if you look at this one, now what you need to do here is basically specify the type. Now let's say I want this method now to operate on the string type. Look at that. The moment you do that, the moment you specify, look at this. For or equal, you're saying the type is going to be string. So obviously for this t, it's going to be string, which means value 1 and value 2, both of them have to be strings. But if somebody tries to compare integers and strings, let's say if somebody tries to do that, we immediately get an invalid arguments compiler error because it's expecting string comma string, but you're trying to pass an integer and a string, which will not be allowed. So we got that strongly typed nature back. Okay, that's one thing. And here boxing and unboxing will never happen. Let's say, for example, if I want to compare two integers, okay, now when the moment I open this, look at that. Okay, now it's going to operate upon integers. Okay, it's not system.object. Integer is a value type. It's going to stay value type during that comparison. It's not going to be converted back into a reference type. Boxing will not happen. So we got that performance gain as well. So now let's say I want to compare 10 comma 10, which are equal. Now if we run this, obviously they are equal. So now your code is actually type independent. So generics are nothing but this. Okay, generics make your code type independent, and that way you can reuse your code with any type. And obviously when you use generics, you get that strongly typed nature, number one, and you also have that performance gain from unnecessary boxing and unnecessary unboxing. Okay, generics actually are extensively used with the collection classes that are present in system.collections.generic namespace, which we'll actually be talking about in the next session. All right, now if you look at this one, here we made this method generic. Okay, it's also possible to make classes generic. Instead of saying, okay, I want this method to operate on any type, you can say this class basically can operate on any type, which means all the methods in this class are going to, in a way, operate on that type. For example, instead of specifying this t here, what you can do is you can specify that t for the class itself. So now you're making the class generic. So instead of specifying the type here, you specify that on the class. Maybe I want this class to operate on int data type. Okay, the moment you do that here, look at that. This method is going to expect integer data types. Look at the IntelliSense. All right. So now if we run, as you might expect, the output will still be the same, except that in this case, we